Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at unique triangles. So a triangle is unique if it's the only triangle that can be drawn with those dimensions. In other words, any triangle with those dimensions will be congruent to the original. Okay, probably doesn't make a lot of sense. Let's look at an example. So let's look at this triangle here. I'm asking, is this triangle unique? So when I say, is this unique, I mean, can you draw another triangle with these dimensions that is not congruent to this one? So if you tried to draw a triangle with side lengths 1, 2, and 3, you'd end up with something like this. And these two triangles must be congruent. They are congruent by the SSS test. It turns out this triangle is unique. A triangle with side lengths 1, 2, 3 units is unique. Any triangle you draw with side lengths 1, 2, and 3 units will be congruent to this triangle by the SSS test. That's what we mean by unique. So you use the same tests for congruence as for unique. So for example, if I have a triangle like this, let's say this is 2, this is 3, and this is 20 degrees, that triangle would be unique by the SAS test. If you have two side lengths and the angle between them, there is only one triangle that you can draw with those dimensions. Any other triangle you draw with side lengths 2 and 3, angle between 20 degrees, it will be congruent to this one. So what about this? How many triangles could be drawn with two angles equal to 30 degrees and a side equal to 5 centimeters? Well, we can obviously draw one such triangle, so let's draw that. So here I've drawn a triangle with two angles equal to 30 degrees. Obviously that means it's going to be isosceles and these two sides will be the same. So I need to put in a side that's 5 centimeters. So I could either have the 5 centimeter side here or here. So here I have two triangles with two angles 30 degrees and one side 5 centimeters. Now, these two triangles cannot be congruent. Why is that? Well, see, in the triangles, the largest angle would be 120 degrees. See, in this first triangle, 5 is opposite the 120 degrees. So it has to be the longer side. Here, 5 centimeters is opposite the smallest angle. So it has to be the shortest side. So in this triangle, 5 centimeters is definitely the longest side. In this triangle, there must be a side longer than 5 centimeters. These two triangles cannot be congruent because they have different side lengths. This triangle has a side length greater than 5. This one does not. So this triangle is not unique. A triangle with two angles 30 degrees and one side 5 centimeters is not unique because you can draw more than one non-congruent triangle with these dimensions. So why is this the case? Why is this not unique when I gave you two angles and a side length? Well, you might be thinking, hey, can't we use the AAS test here? The problem is we can't use the AAS test because I didn't tell you where the 5 centimeter side was. To use the AAS test in congruence, you have to have two angles, but you also have to have the corresponding side. That's why the AAS test doesn't apply here. 5 centimeters here is not the corresponding side because here it's the longest side and here it's the shortest side. If I said to you, how many triangles could be drawn with two angles 30 degrees and the shortest side was 5 centimeters, then it'd be unique by the AAS test because I've given you two angles and a corresponding side in each triangle. But because in this question I didn't make that the 5 had to be corresponding, I can't use the AAS test. These triangles are not unique. We have two triangles with these dimensions drawn that are not congruent. Alright, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.